Good morning, everybody. We're going to talk about Chapter 7.6. This is the last section of Chapter 7.6, last section of Chapter 7. So we're going to talk about, again, we're beginning algebra. We're in Chapter 7. Chapter 7 is rational equations. 7.6 is Chapter 7 is rational expressions. Chapter 7.6, Section 7.6 is rational equations. So equation is going to be the important part here, and this is our video A, the first video that we're going to talk about. We're going to talk about two different subjects in this video. Introduction to rational equations, that's going to take about one slide, and then we're going to start solving rational equations. So when we're going to find out that when we've got rational equations, it's a lot like when we've got equations with fractions in them. We're going to do something special, and that's actually going to be clearing fractions. Very similar to clearing fractions. So let's go to the introduction, basically for 7.6, rational equations. What is a rational equation? Well, it's, historically, what have we done? We've seen, things like linear equations, ax to the first power, and this is just kind of looking back in the rearview mirror, seeing where we've been. Linear equations are ax plus b equals 0. That's an equation, and that's a linear equation. It's kind of basically just on a number line. If we talk about quadratic equations, it was ax squared plus bx to the first power plus cx to the 0th power. And that was a quadratic equation, and that would be something like that. So anyway, that's kind of looking back in the rearview mirror. But now we've got a new equation here, talking about a rational equation. A rational equation is the equation with one or more rational expressions, and essentially that's one or more fractions. So a rational equation is an equation with fractions. And what do we do when we've got fractions? We like to clear them out. So we've got to go talk about step 2 now, solving rational equations. If we're solving rational equations, anytime we see a rational equation, rational means fractions, equation means we've got an equal sign. So if we've got an equal sign and we've got fractions, then we need to clear those fractions. For review of clearing fractions, we can go back to, I guess, 2.3 in the textbook, or we can kind of go through it here today real quickly. If we're going to clear fractions, we simply find the lowest common denominator of all the fractions, and then multiply all the terms. In the book it says the left side of the equation and the right side of the equation, or something like that, by the lowest common denominator. But essentially, we've got to multiply all terms by that lowest common denominator. So here's an example. Solve. Well, let's see, if we've got an equal sign, we've got an equation, and we've got a fraction here, we've got a fraction here. Anytime we've got a fraction and an equal sign, we've got a rational means fraction, and equation. So we've got a rational equation. So we now have to find, we've got to clear the fractions out. So what do we have to do? We've got to find our lowest common denominator. Lowest common denominator includes every single factor from every single denominator raised to the highest power. This would be, the factors here would be just 2. The factor here would be 2 times 2, or 2 squared. So the lowest common denominator includes every single factor from every single denominator raised to the highest power. It'd be 2 squared equals 4. Not too difficult. But now, after we find our lowest common denominator, we multiply every single term by that lowest common denominator. And what happens there is that it cancels out all the terms, or all the factors in the denominator, and we can have then everything on kind of the main floor, if you will. We will have everything over a common denominator of 1. So let's take a look at what we're going to do here. We've got to take this entire equation, we've got to multiply by 4, our lowest common denominator. What that means is we're multiplying this term by 4, we're multiplying that term by 4, and we're multiplying that term by 4. So essentially we're multiplying every single term. Y over 2 times 4, y over 4 times 4, 6 times 4. When we do that, we'll find that we will clear out some of these. Well, in fact, we'll clear out all the fractions. 4 over 1 times y over 2, well, the 4 cancels with the 2 to give me 2, and my answer is, for that term, 2y. Plus, well, the 4 over 1 cancels with the 4. 4's cancel out, and I have just plus 1y, or just y, equals 6 times 4 is 24. And now that I've converted my original rational equation or fractional equation to something that we can easily work with. So now we say 2y plus y is 3y equals 24. Divide by 3 and divide by 3 and we get y equals 8, and there's an answer. And we'll find that that one is a lot easier to work with. This equation is a lot easier to work with than the original equation, just because the original equation had fractions. We would have to, could we convert this y over 2 and the y over 4 to a common denominator? We certainly could, and then we could solve that way. But, the easier way to do it is just to clear out the fractions by multiplying by our lowest common denominator. So let's kind of look at some of the rules here. So here are the steps to solve a rational equation. Remember, rational means fractional. Equation means we've got an equal sign. So if we've got fractions and an equal sign, take these steps. Number one, factor the denominators of rational expressions, and then determine the domain restrictions. In other words, if we went back here, we'd have to say, well, domain restrictions are, let's see, in the previous section, we didn't talk about domain restrictions. We talked about restricted values. So if we're talking about restricted values are the times when we're dividing by 0. So over here, we're not dividing by 0, so there was no restrictions on what y could be. So that's what we mean by determine the domain restrictions, determine the restricted values, determine the values for y, or whatever variable we were using, that would create a division by 0. That would be a domain restriction or a restricted value. So step number 1, factor the denominators. Step number 2, what is the lowest common denominator? Step number 3 is multiply both sides of the equation by the lowest common denominator. And we could substitute in, instead of both sides of the equation, we could substitute every single term in the equation by the lowest common denominator. And then solve, and then do a double check. So let's go to a different example. Let's go to a second example, I guess. So here's our steps we have to really kind of wonder about and really kind of make sure that we do. Find the lowest common denominator. We know how to do that. Essentially, we've got to factor and then list all the factors. So identify the lowest common denominators. Then we've got to multiply by the lowest common denominator and then solve. So when we see a rational equation or fractional equation, then let's do it. So here's our fractional equation. So here we've got some variables. In our previous example, we just had numbers in our equation, or sorry, numbers in the denominators of our equation. Here we've got variables also, but if we've got variables, essentially it's the same thing. We've got to just find the lowest common denominator, multiply all terms by the lowest common denominator, and solve the equation then. So if you're looking for something to add to your cheat sheet or your study guide, right here, the stuff underlined in red is kind of a simplified version of what we had over here. So here's our steps to solve the rational equation. Essentially, find the lowest common denominator, multiply all terms by that lowest common denominator, and then solve. So let's take a look at what we've got here. We've got to pay attention as well to restricted values, but we'll take a look at that in just a second. If we have a rational, means fractional, equation, then what do we have to do? Number 1, find our lowest common denominator. Lowest common denominator includes every single factor from every single denominator raised to the highest power. We've got to have an x. We've got to have a 3. We've got to have 6 factors to 2 and 3, so we've got to have a 2 as well. So lowest common denominator equals x times 3 times 2, or 6x. There's our lowest common denominator. So there's our lowest common denominator. Step number 2 is multiply all terms by the lowest common denominator. Now before we do that, we should probably find, because we've got an x or a variable in our denominator, we should find out what the restricted values are for that. Remember that restricted values are, or happen when we divide by 0. So if x is equal to 0, then we're dividing by 0. So we have to go over here and say, oh, somewhere we should say x not equal to 0. So x cannot be equal to 0, because if x is equal to 0, then we're dividing by 0, so therefore x is not equal to 0. The other way to say it would be x equals 0 is a restricted value. And that would be from a previous section, that, talking about restricted values versus this way to write it. So x is not equal to 0. because otherwise it's dividing by 0. But now we're you're coming back to where we were at. Find the lowest common denominator. We did that. Multiply all the terms by that lowest common denominator. So we're going to take this term, multiply by our lowest common denominator, 6x. We're going to take this term, multiply by our lowest common denominator of 6x. We're going to take this term, multiply by our lowest common denominator of 6x. And now we just multiply through and get rid of everything that's in our denominator by canceling out factors. So 6x times this fraction divided by x. Well, the x's cancel out, and you can say, well, it's 6x over 1. X divided by x is 1, and that's a factor, and that's a factor, so we can cancel those out because we can, remember, cancel factors out. Here then we've got 6 times x plus 1 as our first factor. Second factor is 6x over 1 times 1/3. Well, the 6 cancels with the 3 to give me a 2. And now I've got 2x times 1, or 2x, and I've got a plus between them. So we canceled the 6 with the 3, and we got 2, and 2 times 1 is 2, and x is still there as well. The last term is equal to 5/6 times 6x, or 6x over 1. 6 cancels with 6 because they are both factors, and what do we have left? 5 times x, 5x. And now this equation is very simple. It's simpler to, or much simpler to solve than our original equation. And all we have to do is now distribute this and then solve for x. 6 times x is 6x plus 6 plus 2x equals 5x. Combine like terms on the left. 6x plus 2x gives me 8x. There's a 6 plus equals 5x. And all we did over here was combine the like terms. 6 plus 8x equals 5x. Now we have to move the variables to one side, numbers to the other. I'm going to choose to move the variable to the right side by subtracting 8x. Let's subtract 8x on the right side. I have 6 equals negative 3x. Divide by negative 3, divide by negative 3. We have negative 2 on the left side equals 1x, or just x. And there's our solution. X equals negative 2. And that does not violate our restricted value of x cannot be equal to 0, so we're pretty much done. So we've solved the equation by clearing out the fractions, and we can only do this if we've got a rational fractional equation. So if we have a rational fractional equation, we find the lowest common denominator, multiply by the lowest common denominator to kind of get rid of everything in the denominators, and then we solve the mini equation, or I guess solve the simpler equation.